All right. Hello, everybody, and welcome to the stream. My name is Nick Larson. Today is October 16th, 2019. It's 12:02 in the afternoon, and we got a blank slate. Let me close some stuff down real fast because I don't want to open that stuff. There we go. Let's open up something new. A little new incognito window. All right. Let's talk about what we need to do today. Today is something for work that has come up. Actually, before we get started with this, let me just go ahead and give a shout out. Thank you, Rambling Geek, for the raid last week. It happened right at the end of my stream. Did not get to it, but I really appreciate that. Beachcast, thank you so much for the follow. I really appreciate that. And Sleventh Heaven, thank you so much for the follow as well. I need to go ahead and actually follow Sleventh Heaven because let's just go twitch.tv. Follow. There we go. Okay, cool. Done. All right, what are we going to do now? We are going to talk about what we're going to do. That's what we're going to do. Okay, today's task is... Just move it over a little bit. There we go, like that. Okay, we have a large number of tasks, like in an array. And I mean a large. Like, think of it like something on the order of like 10 million plus. Okay, tasks. And each of these is going to happen very fast. Why are they going to happen fast? Because they're running against Redis. Redis. Okay, but it doesn't really matter that they're running against Redis. All that matters is that they're fast, short-lived. Short-lived. Okay? And what we want to do is we want to process these as fast as possible. Okay? In the past, the way that we would do this is we would create a batch. And what we would do is we'd say, like, give me 100,000, and then create 100,000 Redis tasks and go fire them off. Okay? The only problem is, when you do that, you're creating a queue of 100,000 things that needs to finish. And then when you're done, you say, go execute all of these 100,000 things. And then you say, wait. Right? So basically, it works something like, let me just go ahead and write some simple code here to give you an idea about what's happening. Let's make it bigger so everybody can see it. It goes like, you know, var things to be done equals, new work, unit of work, array 10, what's the right way to do this? Something like this. And then you would say something along the lines of, for each var batch in things to be done dot batch, 100,000. And then you would say something like, give me just a moment here. And then you would say something like, var task equals batch dot select, unit of work. Okay, do unit of work, or what is it? Async unit of work dot execute async dot to array. Okay, and then that would be your task, and then you would say something like task dot wait all task. And then this would go and go and go and go. And what you would do is you would say, do 100,000 of these at a time, do 100,000 of these at a time, do 100,000 of these at a time. Let me execute that. And then let's go with something like this. I can say, yeah, like, do 100,000 of these at a time, wait. Do 100,000 of these at a time, wait. Do 100,000 of these at a time, wait. And what ends up happening is a couple of problems. The first thing is there's a lot of batches, right? There's, 100 batches here, but realistically, this can actually get quite large. And you can't always run 100,000 because some of these tasks take longer. And so what you do is you say, okay, this is timing out, because this has a wait time attached to it, and you don't really want to turn that wait time up, because if it does take longer than that, you want to identify that like something is taking a long time. You don't want to just decide to wait endlessly, because that's better, right? So instead of doing that, what we want to do is we want to say, do a task, and if any given task takes too long, we want to report it. And instead of waiting until all of the tasks complete, why don't we just go and work on something else? So we have a bunch of threads. And we want each one to be constantly choosing and doing new work instead of, it sort of working until they're all done, creating all these tasks and then stopping, creating all these tasks and then stopping, and being hung up on this step, on the one that takes the longest. Now, usually these things are extremely short-lived, like less than a millisecond. But in some cases, these things are not exactly short-lived, more like, 30 milliseconds. And if you get 3 of those that end up running on the same thread, now all of a sudden you have quite a large problem, because now all of these tasks, which take very quickly, are waiting like 60 milliseconds for your batch to finish. And if your batch size isn't 100,000, but it's 5,000, well, now you're running, 2,000 of these? And that starts to take kind of a long time, like 15, 20 minutes. And so we don't want to do that as much as we can avoid it. I got things beeping everywhere. Give me just a moment. So the plan today is to get my phone to stop beeping. Give me just a moment here. Yep, do that. Okay. Quit that. Quit all of this jazz. We don't need this. Nope, nope, nope. Stop. Okay, that ought to take care of it. Okay. So the plan now is basically, instead of having this batch step, we want to replace this batch step by saying like pipe to and do something and, say like the maximum number of threads that you want to use. And that can be configurable to be whatever it is that you want to, be. You might do like 100. You might do like environment times the number of processors times 5. Like whatever the choice is that you want to end up making here, you can sort of, figure out what it should be. Trial and error. But I want it to be so that these threads are just constantly grinding and grinding and grinding, and we don't have this intermediate wait. Like as soon as one thing is done, it just goes on to the next one. It just goes on to the next one. It just goes on to the next one. There's no synchronization point where it needs to go and stop the whole world to go wait for everything to stop and then get more work to do. I want it to just grind through work until things to be done is gone. Okay? Why do we want to do this is also a good question. The reason we want to do this is because right now we're running into an issue where we switched from an old version of Stack Exchange Redis to a new version of Stack Exchange Redis, and all of these batch sizes are now broken. For every single one of them in the code base for the project that I manage, they all started timing out, every single one of them. So we've been going through and like cutting them in half. If it was 100,000, we changed it to 50,000. If it was 50,000, we changed it to 25,000. If it was 10,000, we changed it to 5,000. And all of these things make the whole like task, this tool, this application is running like say 25 different tasks. And each one of these tasks, each one of these processes has to now take a little bit longer to account for this. So we want to get to the point where we can speed this back up and also stop the timeouts. Just absolutely. Just no matter how fast it is, no matter how slow it is, it'll just work. And if it takes too long, then we can log it. But for the most part, that's it. And so that's what we're going to do. There is an example of how to do this, and we're going to start from there, and then I'm going to explain why I don't like it. And then when we're done with that, oh, give me just a moment here. I got to change some stuff around. I'm going to start with that, and I'm going to show you the code. I'm going to talk about why I don't like it. I'll say, like, you know, it does the job, but it doesn't actually eliminate this problem completely. It still has this like one giant synchronization point. If it takes too much work and it's too complicated to do it the way that I want to do it, then we'll just bail on it and we'll just stick with the way that with the concept that was given to me. But let's just take a look at it, because all I'm doing is talking in non-absolutes right now. So I'm going to hide this and bring up the code real fast. We're going to go to full screen. Okay, you should be able to hear me again. Okay, let me go grab the code real fast. We need to keep that closed. Yep. I am loading up Visual Studio in the background. I am getting ready to get the code. Okay, I'm looking for pipe. This will just take a moment. It's loading a bunch of crap. Now it's actually searching. No, I don't want pipelines. Here it is. Nope, that's jQuery. I don't want content. I don't want pipe delimited. We're going to search better. That's what we're going to do. There it is. Okay. So this all right. Let's copy that. Let's open up code. Actually, we're not even going to open up code for this. We're going to do this all on LinkPad. Okay. Here is the code that was given to me by another team here at my office. Close that. Make sure we don't actually share any of that. Okay, and the way that it works is you pass in this enumerable of the things that need to be done, and you pass in the action that you want to perform on it. So this is an extension function, and what you should see is that you have a bunch of items, and then you say perform this action on it, and then say we want to have no more concurrent actions running than this. So I can say that at any given time there are no more than, say, 1,000 in flight, right? And as one finishes, it'll fire off the next one. As one finishes, it'll fire off the next one. As one finishes, it'll fire off the next one. And then for each one, we can just set this pipe length to be relative to, you know, the maximum load that whatever the thing is can handle. So if we're calling Redis, we don't want to send it more than about, I don't know, 250 or 300 concurrent messages at a time, which would not quite saturate the pipe. But, again, it's one of those things where you can figure it out for Redis and for the kind of data that's being sent. And then hopefully, no matter how big this source gets, we'll never have to change it. That's conceptually the idea. This task buffer right here is a way to just avoid allocations, which I don't actually care about, so we're going to get rid of it. And we're just going to have it be a var buffer, and then we're not going to worry about this at all. Right? I just want to cut this down and make it as simple as possible. All right. Then what we have is I wonder, okay, so all right, so we pass in the total number of things that we want to do at one time. We pass in the action that we would like to perform. This is usually an async action, and the assumption here, I believe, is that this is async. That's why it returns a task, and it just performs the action on the item, returning a task, which yeah, right there. Okay, there you go, func t. So it takes in an item, returns a task, so it is awaitable no matter what. Then we just say, okay, if it's completed, go ahead and wait it so that it performs the follow-up action. And then if it is not completed, then what we want to do is, we don't want to throw it on the thing at all. So instead what we do is we say, go ahead and put the task in the buffer, and then we're going to come back around to it at some point later on. All right, so let's draw what this is actually doing. Right here, let's go ahead and create a new file, new. Sure, 800 by 600, same idea, zoom in, scroll over. Okay, so what this is doing is it's got this, no, stop. Give me the pen. All right, so it's got this array of things to do, and it is saying here is a buffer with, say, this many slots, and they all start out as null. And then it says for each, let me just draw this. This is going to be a lot easier to type. Okay, then what this is saying is for each thing to try, we want to start the task. Let's just do var task equals try thing. And then we say if task is completed, then move on to the next thing. Else, store the task in the buffer and move on to the next thing. Okay? Now, what it does is it gets a little more interesting at this point. So this store the task in the buffer part, it doesn't just store the task in the buffer. Let me see here. Bring up this. What it's doing is it says, go look at the thing that's already in that place in the buffer. And if there is something there, then we have to wait for it to finish. Then when that thing is finished, then we can go ahead and assign this task back to the buffer. Okay? And this has sort of a similar problem, which is basically what it's doing is it says, let me look right here. Okay, if this one is null, then we put it here. Then the next one is null, we put it here. The next one is null, we put it here. The next one is null, we put it here. Next one is null, next one is null. Then it comes back around to the beginning. And when it comes back around to the beginning, it says, oh, this thing is still running, right? So I'm going to wait before I fire off before I store this next task in here, I'm gonna wait for this one that's currently right here to finish. It will not try to do this one. It will not try to overwrite this one or this one or this one or this one, even if these all finish before this one finishes. Okay, and that's my main concern with this whole thing is we still have these like stop the world moments, and they're actually a lot more frequent, right? This is where like making this so large that you would expect this thing to be done by the time you come back around to it matters. But you still have to be gentle, because if you were to come all the way back around, you don't actually want it to start another one until one of these has freed up. But we don't have any information about what's going on down here when we're looking at this section. So that's my main gripe here, and instead what I want to do is something different. Like, let's go ahead and add one more, because this is conceptually the same idea, I just want to change it a little bit. Again, we zoom in. Again, we move it. All right. So same idea. We got the big array up here. Sort of the same idea of having these here, with all of these. Only in this case, there's a task in here, and I want to set a continuation. Okay, so that as soon as this one finishes, it will immediately try to replace itself. And as soon as this one finishes, it will immediately try to replace itself. And that is the trick of what we're going to try and accomplish today. So that you have a set number of these, and you'll never have more than whatever your set number is in flight at any given time. Just the same as the last one. Only as soon as one of these finishes, if this one finishes before this one, we won't get hung up here. We'll just go ahead and fire off a new one immediately. And I don't know if, I don't know the complete internals of any of this stuff. I don't know if setting a continuation is going to be any slower, but I suspect that it is not, for the explicit reason that calling await right here is actually creating a continuation. It's creating the continuation that then pulls back into here and reruns all of this. So that's my expectation. And as soon as it gets through grinding through this entire, thing, then we'll be done. And then this, of course, just says go through each of these, wait for all of the old tasks to finish, and as soon as they're all finished, then, hooray. And in my case, I guess we would still need this a little bit. And that's the plan. That's what we want to do. So we're going to have something called pipe continue. Public static async task pipe continue t this i.e. enumerable t source int. Okay, we're going to call this something like max concurrent task, and then func t of task action. All right, same exact idea. The only issue is now we need to basically have it so that the continuation goes and picks up the next item automatically. And how are we going to do that? To be honest with you, I haven't thought that far ahead. I just conceptually have the idea about how I want to do this. So let's give it a shot. Okay, so in this case, we still want the buffer because we still want to keep track of the number of tasks that we have. Var buffer equals new task of max concurrent task. And it's probably better to call that maximum uncompleted task. All right. And then in this case, we probably don't even need the index at this point. I would say we would want something like, all right, so we basically want to say We want to be able to grab the next one at any given time. And I would like to avoid locking here if possible, but I think for starters we're going to try it with a lock because, you know, these tasks, although they're short, they're still on the order of like, you know, a few milliseconds. And I'm not sure if we can get a lock done in that time. We might be able to do something where we grab a few at a time, like grab 2 or 3 or whatever, and see if that works. But ideally we wouldn't do that. Ideally we would just choose the next one. We cannot pipe these through any sort of like concurrent queue or concurrent dictionary because we cannot enumerate this source because it's not an array. So we have to like sort of go through it at the same time that we're doing these things. And maybe the way to do that is just to say something like, I don't know. How are we going to grab the next item? How are we going to grab just the next item when we need that item? I'm going to, like, ideally I would have a queue and I would say like get next. And then the idea is create, okay, so create or execute for the first action. All right, for each var item and source, I want to say, hey, what's up, TBD Gamer? How are you doing, man? Trying to do something I have absolutely no idea how to do. I don't know if you were here for the explanation of what I'm trying to do, but basically, this is the code that we start with, and it has this like stop the world issue right here, where like, let's say you have a pipe length of say like 1,000, and it goes around and it comes back to that first one, and that first one takes a long time, but these other ones back here finish. I want to be able to have those go ahead and start taking on additional work instead of waiting for this one to finish. And I'm just not entirely sure how to do it, so I'm sort of figuring this out here as we go. And I'm going to just copy it pretty much for the most part at the beginning here. uint index equals 0. And then I want to say something like, how about var enumerator equals source.getEnumerator. Okay. And then I want to say for int I equals 0, I less than what? Max uncompleted task, I plus plus, if, okay, var item equals enumerator, enumerator, let's just call it Q, because that'll make more sense here. Q dot current, and then I want to say var task. Actually, I want to say buffer of task, no, of index of I equals action of item. Okay. Let's say something like, okay, I need a function. I need a local function. Void, no. Task, do next of item. Hey, Coding Gorilla, how are you? It's good to see you. Task, do next, T item, no, T whatever, yeah, item. And then this is going to be async. And then we're going to have, and let's put an index on it. Int index. Okay. And then we're going to say var task equal, no, actually we're not even going to do that. We're just going to say await action. Yes, we do. All right. I don't even want this item. We're going to say take work. And we want the queue up here. Say void. We're going to say, no, I want async. Okay. Do I want it to be async? Maybe not. Maybe not. Let's just have it be void. So the idea here conceptually is I want to go get something from the queue. So let's say lock, T item. I want to say lock of the queue. And I want to say item equals, or rather, it's the right way to do this. Lock queue. Okay. If queue how can I tell if I'm at the end of an enumerator? I actually don't know the answer to that. I don't work with enumerators that often. C# enumerator end. How to know if an enumerator has reached the end of a collection. It seems to be exactly what I want. Oh, I got it. Okay. Here's a pretty simple way. Move next. Okay. If queue dot move next, or rather, if not queue dot move next, then we can just return from this function altogether. Otherwise, item equals queue dot current. Then I can release the queue so that other things can start taking it. I did what I needed to. I got the next item. Now I want to do the work of that item, which is conceptually await action item, which makes this async task. What in the hell? Oh, you gotta spell the words right. Async task, and then take work. Of index. Which means that, oh, no, the same index. So what we're doing basically is saying we want to write a function that creates a single worker and is storing, the worker's information in a set location. And then when that worker is done, we want it to continue to grab more stuff to do. And then we want it to grab more stuff to do. And then we want it to grab more stuff to do. But then at the end, we need to know that we have reached the end somehow. And that's the part where I'm sort of having trouble with, is figuring out how to signal that we have reached the end. And that we need to now, basically complete the pipe continue. Like, what is the thing that we need to await? And I can't just say, I can't just say, what's going through my head is I can't just fire these off and then await indefinitely. I need some way to trigger this. And I don't even need this right here. Pipe continue, not all code paths return a value. Right, and I'm not entirely sure how to do that. You could capture all the tasks returned from the local function. It's the win all that I'm really trying to avoid here, because the win all has a timeout set to it, and this could take a very long time, and I don't want to have to customize this timeout for all of them. I basically want this max uncompleted task to be my throttle, and I don't really care how long this takes. So the idea here is that the problem that I'm trying to solve is I have a list of say 10 million things that I need to do. It has an overload that waits indefinitely, doesn't it? I don't know the answer to that. Task dot wait all. Specified number of milliseconds. Time span, cancellation token, or until the wait is canceled. I don't know the answer. At least one of the tasks was canceled. Argument contains a null element. I don't know the answer. Let's click on your link here. Let's pull it over here. A win all. The following creates a set of tasks that ping the URLs in an array. The tasks are stored in a list task collection that is passed to the win all so this seems reasonable. Okay, so I have these that are just take work, and then I just say something like, in fact, I don't even need this buffer here. What we can do is say something along the lines of return take work? No. Await take work. This is going to get super nested. Although it's asynchronous, I don't know if this would actually work. Right, this is like recursive that's going to recurse as many times as we have in here. I don't really want to do that. So instead of having it be recursive, let's just do a while true. What are you complaining about? Take work is declared but never used. And then I just have var task, or let's call it workers, equals task, nope, equals enumerable dot range of what, max uncompleted tasks. Do I seriously have to? I have to put a 0 in there. Dot select. Let me see here. I'm switching back so I can see the chat. Okay. Dot select. I guess I don't even care about the index at this point. And then we just have select take work dot to array, and then we have task dot win all workers. I really want to know what the options here are. Okay, so this is just gonna like run forever? Is that what I'm understanding? Is this, please tell me that returns a task. Okay, and then we can just say well until they run out of work. Okay, so this doesn't have a timeout. I guess that's what I'm getting at. This is just going to wait, because these could take like 15 minutes, and I'm pretty sure that the default task timeout is like 20 seconds. And I don't really want to change that if I can avoid it. Okay, so basically all we're doing is creating threads that pull from the queue, and each one does the work. And as soon as one finds out that it doesn't have any more work, then it bails. I can't say that I've ever tested it with anything really long-running tasks, but I don't think it will time out. Okay, well, perfect. I'll take that. We can test that. Also, so what I want to do is I want to basically say we're going to sleep some random amounts of time, and we're going to see which one goes faster here. So we're going to say something like var times equals enumerable dot range. I really wish they would get rid of this enumerable dot range and make it much easier to like create a for, like a range. Enumerable range is just really long. And we're going to say 0 to, I don't know, let's do 100,000. And then what we're going to do is we're going to say dot select. And in this case, what we want to select is, okay, var random equals new random 2019 1016. Okay, it's good enough for me, just for reproducibility. And then we want to say select random dot next double. Okay, and then this is going to be uniform, which I guess is good for now. And then what we want to do is we want to multiply this times the amount of time that we want to wait in milliseconds, which we're going to say is anywhere from 3 milliseconds. Okay, 3 milliseconds to, I don't know, 35 milliseconds, right? Short running tasks. Ideally, I would like them to be much closer to the lower end, but I want a few. Is it easy or difficult to create a normal distribution or from a uniform distribution? I'm going to look that up real fast. Let's go C# random normal distribution. Random Gaussian variables. Okay, I'll take that. So we're going to say double random normal and I don't want this here, and I want this to be 2019 1016, and we're going to call this random normal, and I think this is going to be mean and double standard deviation. We want the mean to be like 10D, and we want the standard deviation to be like 12, 15, 12, 24. You're going to get some numbers that are 2 standard deviations away. What if we just do like 10? Let's just do 10. Okay, and then all we're going to do, actually I don't even want, this isn't the real distribution I want like a log normal. But I'm not going to worry about that at this moment. Got to array. Alright, now what we're going to do, uniform, uniform, and then return ran normal. Let's give some credit where credit is due. Copy link. Okay. Let's put it all on the same line. Like yes. Not what I wanted. All right, so now what we have is a bunch of numbers, and then what we want to do is actually not quite. var rand norm. What I need to do is make sure that it's not below 0 here. Return min rand norm math dot max rand norm 3. Okay, so that's going to make sure that we have no values that are less than 3 milliseconds. It's okay that we're going to have a lot that are exactly 3. I don't mind that at all. What I really am most concerned about is that we have a few that are up here, because it's these few that are up here that are really going to affect the difference here. Okay, now what we're going to do is say var stop timer equals stopwatch.start new. All right. Did you get it working? Sorry, I had to step away. No, we're at the point of testing. Coding Gorilla actually linked me to something that made it conceptually easier to work with, because I was afraid that I was trying to figure out how to trigger the end of the entire pipe here, and he says that, or they say that task.winAll should not time out. It should just wait indefinitely. So we're getting to the point of actually testing this out now. If we're going to do these with say, well, we'll come back to it. So now what we're going to do is we're going to say async, and then I think you have to do util.create synchronization context, and then you say await times.pipe. Oh. Okay, well, we're going to have to just call it the other way. Pipe. And what we're going to have is a function called just sleep. Task just wait, and this is going to be a double milliseconds, and this is going to be await task dot delay, and we want to put in a new time span. We want, I don't really like that. Task.delay milliseconds delay int ms. Close enough. Okay. And then we have pipe of times. We're going to do 1,000 to start. And let's just say, let's make that const int buffer size equals 1,000. Buffer size, and then the action is going to be just wait. Timer.stop, timer.elapsed, .dump, name of pipe, and then basically copy this whole thing again. Only we want to call it pipe continue. Kind of a bad name, pipe continue. Have to come up with a better name. And then pipe continue. Okay. How long should this take? Let's see. We're breaking this into. All right. Each task should do about 100 waits. We have an average of 10 milliseconds, but we're really shifting it up a little bit, so it's probably going to be an average of about 11 milliseconds. So 100, it should be like a little over a second if it does it like optimally. The task.delay is actually really bad way to go about this. Task.delay is an awful way to go about this. Instead of task.delay, so the reason task.delay is bad is because task.delay has the issue of it is going to throw it back on the scheduler, and it's going to take on average like 13 milliseconds. So even these like 3 millisecond ones are going to be slow, which is going to throw off what we're trying to do here. So I think instead of this, we're just going to do like we're going to do something kind of silly. And we're going to say, we're just going to spin. Var time equals datetime.utc now. No, we're just going to do stopwatch. Var stopwatch equals stopwatch.start new, right? The high performance stopwatch. And then we're going to say, while true, if stopwatch dot elapsed milliseconds is greater than or equal to milliseconds. No, stopwatch dot elapsed dot total milliseconds is greater than or equal to milliseconds. Break. And then we just want a return task.completed task. Okay, this again is also kind of crappy because getting this elapsed is also sort of a slow thing, but it's much faster than like this would be like, 1 millisecond, as opposed to task.delay being a minimum of like 8 milliseconds. So I'm hoping that this is just a little more accurate, being like aware in our heads that this is still not super accurate, like in terms of the timing. When you get down into the millisecond range, getting very good times is extremely difficult. Like if your tolerance is on the order of a millisecond, you're going to have a really hard time evaluating that in code in every single way that I know how. But if anybody has ideas to do better than this, I'd be happy to take it. Right now, I think that this is probably going to be like within 1 or 2 milliseconds tolerance, so I feel okay with this. And then let's just see. So this should take about a second to do this one, and hopefully, well, ideally it should take about a second to do each one of these, a little more than a second, and I guess we'll find out what happens. Error compiling query. Extension method. That's right. We don't want this to be that. And we don't even care that these are... Actually, I don't even care that it's static, but might as well. Extension method must be defined in a non-generic class. What? I don't even see where the error is now. Am I losing my mind? It's still giving me that error. I don't even see the compiler output. I guess let's... Compiler optimizations are on, sure. What in the hell? Am I losing my mind? What is it complaining about? No, I got rid of the this. I think maybe it's just like, we're just going to restart it here. And then hopefully it will give us the error. Okay. Oh, this needs to be a task. Random normal. Extension method must be defined on a non-generic static class. What the is it in here? Nope, that one works just fine. Pipe T is an extension. Oh, there it is. Ah, thank y'all. Well, this is taking way longer than I thought it was going to. Why are we at 15 seconds? Okay. Let's dump. You know what I didn't do here? Yeah, no, this should not be times.dump. Those are short. Those are not slow. I'm sorry, those are not long. And I get a couple, like here's the 28 that I care about, here's the 32 that I care about, here's a bunch of 3s that are like very good. So this is sort of exactly what I expected to be in here. I did total milliseconds, right? For the sake of argument, I'm just going to have it print out when it's starting a new task. Console.writeLine task. This is me trying to find the problem. Crap. Let's do a pipe length of like 100 here. I mean, this is exactly the problem that I'm trying to address, right? Which is that this pipe has these like world blocking pauses. I still would have expected it to go pretty fast. So even if you take 25 milliseconds times 100, you should be at a maximum time of about 2.5 seconds, like in the worst case here. Unless there's one that was just like randomly ended up super ridiculously huge. But that is so unlikely. In fact, I can just test that very easily. We can just check the max. Yeah, 50 milliseconds. Okay, so it's doing them. You can see it's still writing them out. And there's 100,000 of them. Alright, so let's try the other one first and just see if the other one is going to actually work a little faster, and then we'll just know whether or not we did the right thing. Which would be awesome. Let's get rid of this because this console is going to be slow. I have to stop pressing Control S. Actually, let's just go ahead and save it because I'm going to keep pressing Control S. Code, culture development. Nope, I didn't mean to go in there. Let's just save it in here. This is going to be fast pipe. Okay. It's possible that this lock statement right here is actually quite slow. Yeah. I press it too, even on web pages when I'm like typing in. I'll press tab to go to the next one, and then I'm just like slamming Control S. And if there is a hotkey on the page that wants to do something with Control S, I get so upset. Yeah. Okay. So let's just try this, right? All right, this as well is taking a long time, so I'm going to guess that this lock is actually quite slow. All right, so how... I guess for the sake of argument, let's go figure out if there is a faster... Like, let's just make it slow enough so it actually finishes. I'm sorry, let's make it fast enough so it actually finishes. So we're going to say that, and we're going to say that. So each one of these should process 10 items. And that's it. And if this... Why on earth did it get a different time? How is that even possible? How did it get a different one? It's being initialized with a seed. I'm going to guess it doesn't reinitialize any class variables. Let's stop it. How the hell do I actually make that happen? Okay. Great. I don't know. I don't know. Okay, new thing. Let's see how long it takes to actually get through 1,000. Let's go in here. Let's just say uint. No. What is it? Interlocked dot increment, and I can pass it a long. Okay. Long processed equals 0. Okay. And then what we want is okay. If interlocked dot increment ref processed mod 1000 equals 0, console.writeLine of processed. Okay. Okay, it's definitely the queue that's taking a long time. Okay. Because it's not even creating the task. There, see, it just got to 1,000. What I should also... Oh, there we go, 2,000. Okay, so we have to get rid of this lock. I'm pretty sure a lock is using a monitor. And a monitor has a delay of some amount of time. So I guess instead of grabbing... instead of grabbing like one thing, we would want to grab... Is there a way to avoid... Okay. Just delaying. You know what? I bet you if we added up all the times, it's not even going to end up being as long as the number of milliseconds that has passed right here. Sound Danish to me. So it's Norwegian. My last name is. Or I guess I should say my family heritage is. Okay, so that took a minute 54. I guess if we just let this other one run long enough, we'll know the answer, whether or not this was faster, and then we can just figure out how to fix this lock. What we want is sort of one thread. Okay. What we would want is one thread sort of doling out, you know, here's your next thing, here's your next thing, here's your next thing, here's your next thing. What are you going to need this async pipe for? Can't you lower the workload to begin with to see the behavioral difference? Yeah, I tried that. Yeah, let's go ahead and do that again, I guess. Let's go up here. I guess we'll just do 1,000. And we'll do something like the buffer size is 100. And we will avoid printing out anything. Okay. I still don't get this. Seriously, stop. Task manager. Link pad. Your query. In task. In task. Now when we run it. Weird. What is going on? How is it that I can provide a seed to a random and it just keeps coming up with different numbers? That is mind-boggling. Okay, the first one took 11 seconds. Wow, that was really close. Okay, so let's do something like this. Let's do something like sum. This is going to print out the total milliseconds, and then what we're going to do is also say, in terms of elapsed, we're going to say elapsed dot total milliseconds, like this. And this is just pipe. Okay, it is basically doing that serially. And that is also basically doing it serially. So I need to break up the work beforehand. Okay, so let's answer the questions here. What are you going to need this async pipe for? I I have like, say, 10 million very short-lived tasks. They are all Redis tasks. So this is actually going over the wire to Redis, doing some operation, and then coming back. These times take anywhere from, let's say, like 3 milliseconds, probably even a little less than that in some cases. Probably as low as 1 millisecond, all the way up to like 45 milliseconds or so. And there's just a ridiculous number of these that I have to do every single day. And so the way that we do it currently is exactly like this, which is basically say, give me a batch of, say, 100,000, and then go fire off 100,000 tasks, and then wait for all of them. And we end up with this like wait, this like stop the world wait right here. And it's this stop the world wait that causes all of the threads to sort of pause instead of continuing to do work on whatever the slowest thread was in all of these threads. And the way that works is it breaks it all up. It's doing it, it breaks it all up, and each thread is doing some amount of work, and whichever one takes the longest, that's how long we end up waiting here. Then we go get the next batch. Learning more. Thank you so much for the follow. I really appreciate that. And then we do this batch. In some cases, we can do 100,000. Like, that's not a problem because the updates are really, really small. In some cases, however, we run into the problem where the updates are sort of large, and we have to drop the batch size down to as low as, like, say, 5,000, but we're doing 6 million updates. And in those cases, hey, found it through the live coders. Thanks. Yeah, so it ends up taking a long time, and the real problem here is that we upgraded from Stack Exchange Redis 1.2.6 to 2.0. Your mic levels are clipping a tad. I don't know how to fix that. I'm sorry. I'm going to keep going, though. I'll take a look at it later. And when we updated, all of a sudden, everything started timing out. We have a bunch of tasks, and we needed to figure out like what the problem is. Like, why are all these things all of a sudden timing out when they worked fine yesterday? And so the way that we were doing this batch is what was identified by someone else here at the office. And they said, okay, why don't we just change the way that we do the batch? And they gave us this pipe code they gave us this pipe code. Let me close this and actually show it. So this was the code that was given to us in terms of pipe code. And then this is the attempt to fix it. And to give you like a very quick, brief overview, in this one, in the way that they gave it to us, it assigns the first task here, the second task, the third task, the fourth task, the fifth task, the sixth task. Then it will come back around and it will wait on this one to finish. So even if this one finishes earlier, it has to wait until this one finishes, and this one finishes before this one can pick up new work. And so the plan was, why don't we switch over and do this, where we have each one of these go and pick up their own next work, right? So we start this task, we start this task. If this one finished already, it'll just go ahead and go pick up some new work. And then we do this one, and then we do this one, and then this one finished, so it goes and picks up some new work. And each one of these is sort of independently trying to go and grab more work off of the queue so that no task is sitting there waiting for very long. And what we've come up with so far is a totally different implementation. And right now, from the times that we have, it looks like they're both running essentially serially, which is awful. Where's the code? It looks like they're both running essentially serially. Let me go ahead and run it one more time. We can just take a look at that. So in the queue of work, there is 11,275 milliseconds of waiting that is necessary. In the pipe, the thing that is supposed to be doing this, like asynchronously, is basically doing it serially. Like it's taking 11 seconds or 11,280 milliseconds to do 11,275 milliseconds worth of work. But I would have expected that since we are doing 100 tasks at once, it should be roughly 100 times faster. Maybe not quite, of course not. But it should be enormously faster than this. And then it turns out that, you know, doing it or doing pipe continue, doing the new way appears to be doing it serially, but also doing it the old way seems to be taking just as much time. So now I'm thinking to myself, like, are we actually like making any progress here? And maybe there's just a better way to do this. Actually, maybe there is a better way to do this. Maybe we don't even need this whole pipe thing. Maybe we can just do as.parallel and then a for each. Let's just try that, right? Like, why write code if we don't need to write code? Let's say we want something sort of like times dot as parallel dot select, and then we can just pass it just wait. Dot to array, and then we just say await task dot win all tasks, and this is going to be not pipe continue, but that's not going to work. As parallel. That's the plan. Holy shit. Alright, well that's the answer right there then. We don't need all of this fancy code. When you have short-living tasks, just run them as parallel. Now let's make it quite large, right? Let's see if we make it quite large again, do we still get the same benefit? Alright, and you'll notice it is not 100 times faster, but it is enormously faster than these other versions. And the code is a whole lot easier. Alright, there is a minor concern with this, which is as parallel, I believe, is just breaking the work up strictly into groups. It's just saying the next one goes to that thread, the next one goes to that thread, the next one goes to that thread. And that's all it's doing. So if one thread got all of the slow ones, then it would not do, then that thread would not do less work. They're all going to do the same number of tasks. It's not going to just assign them out, but I'm not 100% sure about that. I don't know the actual implementation. But let's go ahead and jack this up to 100,000 and a buffer size of 1,000 again. And then, yeah, it partitions the work, so you end up with threads that don't have any work to do while others are still working. Yeah, that's what I thought, yeah. Which is kind of a bummer, but in this experiment, it tends to work better. Can you prioritize the data? You wouldn't know either way which ones are the slow ones. That's right, I have absolutely know which ones are going to be the slow ones. Usually what happens is, I guess to some degree you can know because I am sending it a set amount of data. Like if I'm trying to set, say, 5,000 keys in this task and I'm only trying to set 100 keys in another task, I would expect that the one that takes... Oh, no, actually, that's not going to work like that. Okay, so Redis is serial in the sense that the tasks are going to happen in the order that they are received. So even if you have a like simple update, if it follows a long update and you sent them both at the same time, it's not going to choose to do them at the same time. It's going to do the slow one, and the other one is going to appear to take longer. Right. Okay, another thing I don't like about this is returning me, like, if we jacked this up to not 100,000 but like 10 million, we are now calling win all on 10 million tasks. It's just going to queue them all up at the same time, is it not? Which is not what I want, because this is actually going to Redis and this is still going to take a long time. So that's problematic. Okay. I don't want it to queue them all up. I want it to break them up and do all of the tasks in chunks, one by one. So this doesn't solve the problem. And I can basically just toss this. Yeah. Okay. Let's go back to this for a moment. It is so curious to me. I have a feeling that it's like enumerating this that's causing the problem. Let's test just wait to see if just wait is actually returning the correct amount of time. And the way that we're going to do that is we're going to do double SW SW.stop. No. Okay. Var elapsed equals SW dot elapsed dot total milliseconds if elapsed is greater than that, return elapsed. Why is that giving me hell? Cannot convert double. Return task dot from result elapsed. Okay. There we go. And then what I can do is say, so now I want that back, of course. I want to say times.take 1000. I'm doing 1000 because 1000 is the most that will print out in here. Actually, I don't even want to do that. I'm surprised the compiler lets you get away with that. With this? Okay, so now what I want to do is say, okay, var diffs are actuals equals times dot take times dot as parallel dot select expected equal, okay, new expected actual equals just wait expected dot to array. Then what we want to do is say actuals, let's give a little space in here, actuals dot select m dot actual minus m dot expected. The hell are you giving me hell about? Oh, sure, whatever. Oh, wait. Okay. What the fuck? Am I losing my mind? What is M? I am losing my mind. I have no idea what this is complaining about. In theory, that could have no return value. Yeah. Why is this? I am async. What do I need to await? No, you can't await. What in the hell? I don't understand this. Result, whatever. Okay. Yeah, I don't understand why that's returning, why it thinks that's a task. If I call await in here, should it? Oh, yeah. Never mind. This makes sense. Okay. Async functions return tasks. That's right. That makes total sense. Okay. M dot actual minus M dot expected dot average dot dump. Okay. Average deviance. And then I want actuals dot dump. Oh, geez. Did you see that? Oh, I summed it. Yeah, why is that so big? Maybe I wanted 1,000. There we go. I'm going to go ahead and say that my timing function is doing quite well with an average deviance of less than a quarter of, well, right at a quarter of a millisecond. Okay, so I feel like this delay function is good to go. That's not an issue at all. That's not an issue. Okay. Because you marked it async. Yeah, this I don't actually care about. This was just me right here trying to... Oh yeah, because I have result. Yep. It's fine, whatever. It was just a test. So, alright, so all I was testing here is that the just wait function is good. And I'm going to go ahead and say it's good. I don't see any that are like significantly different. Like there's no individual ones that are just like so far off that it's like blowing my mind. The average amount that it is off is less than a millisecond. Is less than a quarter of a millisecond. And I'm not seeing any. Oh, here's a big one right here. So that one took a lot longer. Maybe these longer ones, 18, 2, no, even these are fine. 14. Yeah, I feel pretty good about this timing function as far as like it creating the delay we expect. So I'm going to go ahead and roll with that. And just say the timing function appears to be good to within about 0.25 milliseconds on average. Okay. And it's really like individual ones were taking a long time. Like most of these are dead on. And then a few of them, in fact, no, I'm not going to run it again. Like here's one that was off. Here's one that was off, but this one was like off by so little. Here's one that was off by a lot right here. Almost a full millisecond. 5/16. Anyway, we don't need to keep looking at this. I feel good about that. Now what we need to do is figure out how to make these things not run in basically... All right, if we can just avoid this lock. If we can avoid the lock. Is it possible to avoid the lock? What if I use a buffer? So I've run into this problem before. What if I use a buffer to get as many of these as possible? You know, let's get like, say, 10 of them. What? I need a way to get some work. I need a way to grab work off of the queue very quickly. Can't you use an index and increment it with the interlocked class? So I just have an enumerable, so I can't index directly to an item. I have to say, go get me the next thing. And what I really want to have happen is I want the next, like, few things to have already been gotten for me. What if... Alright, what if... Okay, here's a fun one. Alright, what if we do a while true? Alright, conceptually, this is going to be the thing that does the work. And then we're going to have this right here be a producer. So we're going to create a bunch of consumers, and then we're going to have a single producer that is responsible for looping over these things until it finds one that's ready to do work, and then it's going to be like, okay, go do work. And then when this gets done with its enumeration, then it'll be good. It's going to be a lot of spinning here, so we're going to like really grind on the processor, which is kind of a pain. But it would dole the work out. I would rather have the thing be like, I'm ready for work now. Or I would rather have each of these things sort of have a queue of work to do. So what if I created a worker, and then the worker can continually take more items, but it would have a limit to the amount I would be willing to give to it. You should create a pool of tasks. A pool of tasks. So if right now I believe that the issue is calling this lock, which says you can't have more work, or you can be the only person that is trying to acquire more work at this moment. And I would instead like to have one thing that is responsible for enumerating this so that we can avoid the lock. And then when these things are given work, creating a lot of tasks is not a light operation. That's fair. I would imagine that, like, within the app domain, there is a task pool. And, well, I mean, in this case, I'm only creating 10 tasks or 100 tasks. And then each one of them is continuing. Does this create tasks right here? I guess that creates tasks. Another thing we might be able to do here is configure await false. So that it does not have to return to the same thread. It can go to any available thread. I don't know. Right, let's try that. Let's do the pipe continue. Pipe continue is the first one. If this takes more than 11 seconds, well, no, we didn't do anything. And it's definitely going to take 11 seconds. Okay, still takes the same amount of time. How can I tell? Can I prove? I'm just pretty certain. Man, I'm a little stumped. I mean, clearly this is not good, and clearly we can do much faster. Like, we got it down to 800 milliseconds by doing the parallel. So why can't we make this faster? Have you tried to lower down the number of concurrent tasks? No, it's a good question. So we had 100. Let's do 10, right? That's an order of magnitude. Yeah, no, that's a good call. Still the same amount. It was a hair faster, but still the same amount. All right, so we still have this synchronization point of going and having a bunch of things ask for the one thing. How can I avoid a bunch of things asking for the one thing? Okay. Okay. I understand what you're saying about the interlock.increment now, and that is the path I believe we want to go. How? How? You pretty much always lock the queue. Okay, so we want a buffer of the next item to be processed. Okay. Okay. So we want var next items equals new nullable t, which I can't use. Whatever. Okay. So class any nullable of t is public bool has value get set and public t value get set. I don't want that to be a class. I want it to be a struct. And then I want to say new any nullable of t. There we go. Array of max uncompleted task. So the giving and the taking part, I can't guarantee that. Well, I guess I can guarantee that. No, I can't really guarantee that this enumerator is going to be faster than the consumer, because it's just an enumerable. Like this, each one of these could be going out and like making a database query for all I know. So I can't guarantee that the work is going to be there, which makes this even worse. So maybe the right idea is I wonder if there's an async enumerator. C# async enumerator. In C#8 there is. Ah. Well, I guess now. Okay. I am definitely not on C#8. Am I? How can I figure that out? I can say, what is it? Figure out version of, okay. C# get .NET version. Environment.version. Sure. Environment.version.dump. Yep. 4.0. I'm gonna guess that's. I don't know what version this is. Is there like a link to it? Because that would have made this really easy. Environment.version. Okay, so this is .NET. All right, so let's go to Edit, Preferences, Query. It's a program. Use experimental Roslyn assemblies. What if I want to change the version of .NET? Come on, give me a .NET version. There's no .NET version. Shit, that would have been way too easy. Debugger. Web proxy. Folders. Results. Cancel. Edit. F4. App.config. Advanced. That would have been way too easy, right? Linkpad5.config. Can I change the .NET? I can't really change the .NET version in linkpad. Well, let's go ahead and check it out. Browse. I am paid. I am licensed. Can I do it now? Linkpad 6. Let's see if I'm on Linkpad 6. Help. About Linkpad. Linkpad 5. Oh. Check for updates. Linkpad automatically. You have the latest version. A beta version of the next available. Crap. Okay. That would have been way too cool. It's alright, I probably couldn't do that in my application anyway. But just to check and see if it was going to work would be cool. So instead... Can I get oh, all right. This is going to sound crazy. What if each of the threads enumerates the list? Like, what if I pass this? No, I can't do that, can I? I can't. You can only enumerate an enumerable once, right? And no, not an enumerable. You can only like an enumerator can only go over it, but you can definitely have more than one enumerable, or you can iterate the same list more than once, right? Like for each var I and source, for each var j and source, if I equals j, console.write line same, right? Something like this. Why is it complaining? Oh, sure. Dot equals j, something like that, right? You have to get a numerator for each thread, right? But I don't have a problem doing that. The only problem I have is determining whether that work has already been done or not. By one of the other threads. I just can't for the life of me figure out how to avoid this lock. I just can't figure out how to avoid this lock without going and grabbing the first in items off the queue. Which maybe is the correct answer. I can think of a few ways to reduce the locking, but not eliminate it. I mean, I am all about reducing the locking. I mean, what if each one pulled like 10 items, right? It's really fast to pull them. The slow part is actually doing the work. So if we only have to... The only problem is... Well, no, because it would take about the same amount of time. Okay, well, let's just try that. Let's just try that then. Oh, God. I pressed a button. Okay, so let's just say we want... what is this? Var buffer equals new t array of, I don't know, 10. I'm just making this up. You can lock another object instead of the queue object itself. If that'll make it faster? So I believe that, like, so this right here basically translates to monitor.enter of, you know, queue, and then at the end to monitor.leave, or what, exit. And it's that monitor.enter that I believe is actually taking the time. Like, I think this right here, this lock, the actual act of locking, takes something like a few milliseconds. And I believe that's where this thing is getting hung up. I don't think it would make any difference. Okay. So let's just have a buffer, and then if you get it, then we're just going to say for int I equals 0, I less than, and let's just do the old int I less than 10, I plus plus. Then right here, I just want to say grab me 10 items. Right? And in this case, I want to say break. Otherwise, I want to say buffer of I equals Q dot current. So we're going to take 10 items, and then we're going to say for no, we're going to take 10 items, and then we're going to say for int j equals 0, j less than I, j plus plus. I have to move that out. J plus plus. Buffer of j if I is less than 10, then break. So this will still have a condition to get out of this while loop. And then even if it comes back around, it will immediately have an I of 0. It will not run this. I will be less than. It will break. Okay. So conceptually here, we're just going to grab 10 items at a time so that instead of having to lock 10 times, we only have to lock 1/10 of the time. And unfortunately, I don't like having two configurable numbers. I would like to come up with something better, but just to see if it actually matters and makes a difference. Don't care about any of this or this. Okay. Buffer size 10. Number of items 1,000. The hell is... How did that complete immediately? I must be returning somewhere. Am I losing my mind? I didn't even print these out. I have to be returning somewhere. I must have had something highlighted. Oh, you know, we want that. Okay. Okay. Come on now. Did not help one bit. Oh, man, it's like what? Maybe. Yeah. For the sake of argument, let's just buffer up 100. Is every solution leading to the same answer? Yeah, it does feel like that. That did not help at all again. This is extremely frustrating. Because in this case, we should be locking exactly 10 times. Oh. Yeah, no. We should be locking exactly 10 times. We should be literally collecting all of the work that we need to do. Literally all of it. Is 11 seconds the sum of the wait times? Yes, that is exactly what it is. Times.sum.dump. We use this code right here to verify that the waiting is actually waiting very, very, very close to the time that we are specifying, all the way from 3 milliseconds up to however high it ends up going. And then and then somehow, even though we are literally queuing all of the work that we need at one time, like this whole step can't take more than a millisecond. Literally cannot take more than a millisecond. I guess I didn't actually create explicit threads, but I would have assumed that it would try to complete them on separate threads. Is the method async? Wait, we're waiting for 11 seconds. Why would you expect it to run faster than 11 seconds? I would have expected the task parallel library, when I queue up in a wait, when I queue up a task that is not completed, right here, when I do this, literally saying go create 10 tasks, that as soon as I hit this first await, it's going to continue and do this again. So it should start the second one as soon as the first one gets to here, which would start it on a new thread. Or am I wrong about that? I mean, clearly I'm wrong about that. Here's an idea. Let's just dump out the thread IDs, right? I mean, I didn't see async on the pipe continue, so maybe it waits. Yeah, it would continue. Still has a total of 11 seconds. But this shouldn't have 11 seconds, right? This should have each one. It should just wait until each of these are done. And each of these is doing 100 tasks that take roughly 13 milliseconds apiece. So this should be about 1.3 seconds. Actually, it's 1.1 seconds. It should take 1.1 seconds. It's like, are they run serially? Let's go ahead and, you know what we should do here? We should see where they finish. Thread dot current thread dot ID. Is there an ID? Is there a thread ID? Manage thread ID. Manage thread ID. Dot dump. They still have to add up to a total of 11 seconds. I feel like I'm missing something here. They are all running on the same thread. Okay, confirmed. even if they run in parallel, they still have to add up to a total of 11 seconds. This config... Okay, so these are just like deciding not to run... So this is frustrating. No, there is no task.delay. We got rid of the task.delay for our own. Oh. I still would think though. Why? This is queuing up an action. This is queuing up a task. And for some reason, just completing serially? Eve... Yeah. Okay. So what you're saying is because this is not actually async, it's running everything in parallel? Because it's just running it immediately and then returning the task. That kind of makes sense. Okay, that kind of makes sense. All right, well then let's do this, right? Okay. Return. Wait, no, we still want. Okay. Control Z. We're still gonna want this, and we want await task.delay of milliseconds. And we need to make that into an int. What the hell? Async. And then we want return sw.elapsed.total milliseconds. Okay, and then we're going to run this again to see if it actually, oops, is the time that we care about. LinkPad has detected a possible dead link in your code. That's great. Why is that? Am I missing something? Oh, maybe these dot results. Let's go async await. Okay, again, I don't actually care about the times here. Wait, what the hell? No. Just wait. Configure await. False. That result. No. Let's just do it like this. Okay. Task. Okay, win all. Task.win all actuals. Okay. Then we say dot result dot result. Coding Gorilla. Are you wanting to... Oh, wait, I'm behind. Yeah, I agree. There's nothing to yield to. Your threads can't get preempted, so you're only as async as the code underneath you. Are you wanting to sort of run the just wait in a fire and forget fashion so the queue finishes but the work might still be going? No, I need the response back before I can start picking more work off the queue. Okay. Average deviance, 10 milliseconds. All right, well, that is like unusable. Fuck. That's not super usable, but interesting. Okay, so this is super interesting because you'll notice that it finished in 4 seconds here, which means that this does actually run in parallel now. Let's just go ahead and... All right, 10 milliseconds is awful. But at least we're more in the realm of, like, actually doing things asynchronously. And you can see that we are, in fact, running on different threads. Although these two finished on the same thread. These two finished on the same thread. I don't really care about that. What I care about is that this thing that was taking 11 seconds if we do it serially took 2 seconds doing it my way and took 2.5 seconds doing it the other way. So I feel like there is success here. And all of a sudden, I don't even want this buffer size anymore. I want to go back to what we had before. So I'm just going to say, copy this, because we're going to see if it actually matters, if the buffer size matters. Buffer, and then we're going to change this one. And we're going to say T item. Oops. Okay. Okay. So it can never be faster than the total time it takes to complete the work. I'm visualizing this as how they measure game time played. When they say 10 million hours of games have been played, it just means 5 million players played for 2 hours. Right. Oh. Damn it. Got to do one more of these. And this becomes buffer. Pipe continue buffer. Buffer. Oh, even faster. All right, so the buffering is actually causes a little pain here. Okay. This feels like a win. This feels like some success. And to boot, yeah, I absolutely can share the code. Control A, Control C. This is in LinkPad. This should work just fine in the free version. And also, if you change this main function, if you make this a class, this ought to just run. Let me go to github.com/gist. File name. Pipe methods.link. Create public gist. Gist? Gist? What do you think? Sorry, I mean to say please there. Oh, man, you're fine. Okay. Absolutely. And I appreciate y'all hanging out and like working through this with me. Like that was really bumming me out. Okay, so I don't like that this whole thing takes a long time. I would love for this to be much more measurable. I wonder if that's even possible. How can I like... You know what? Let's go to reference source. Reference source. And I don't want to do task.winAll. I want to do task.delay. Let's see if we can figure out how it's done. Task.delay. Delay milliseconds. Okay, delay milliseconds. If it's less than -1, throw nonsensical. Sure. If it's already canceled, bail. Okay. Promise. Delay promise. Oh shit, did not mean to do that. Delay promise. Cancellation token. Return the promise. I'm guessing the promise is a task. Sure. Okay. Internal void complete. Delay promise. Add to active tasks. Okay. Although unfortunately... Oh, interesting. So task.add to active task is a thing? This must be the task class. Okay, it is. Current task, task.id equals task. Okay. And then whatever calls complete. Oh, interesting. So this is literally just taking a task, putting it on the scheduler, and then whenever the scheduler comes back around, wait, debugging enabled. This dot token equals token. Does it set succeeded? Try set canceled. Where the hell does it actually use? That's weird. I don't see anything about a time. Does... What? Am I missing something? There's a timer. Maybe it gets set. Okay, task.delay. Create the delay promise. Oh, I see. Promise.timer equals new timer. Oh, all right. So we're still stuck on the whole timer thing. So all we're doing is creating a task, registering the task. Nope, I don't even see that. we're creating a task. Maybe there's something about how, all right, so we call base, which just calls base. Interesting. I don't understand enough about this. I don't see the part where like, all of this is like doesn't happen in production. So all we do is literally just create a task called a delay promise. Hey, thank you so much for the follow, VJ Kennedy. I really appreciate that. Right now we're trying to figure out what makes task.delay actually asynchronous. And it's like, okay, so debugging not actually enabled. The timer makes it asynchronous. Yes, I get that this calls the task.complete, but this means that timer itself is asynchronous. Timer uses Windows system function, I think, so it ends up waiting on a callback from the OS. Ah. Okay. Okay. Let's go back. How is this actually called? It takes the state. All right, this is the trigger when it completes. I'm guessing the promise is the state. Yeah. Okay, it is. And then this is the milliseconds that we want to delay. And you have a timeout set to infinity. Sure. Makes sense. So we go forward. We say that this says timer setup. Okay. In the FF, anyways, God only knows what kind of XPlay voodoo they use in .NET Core XSplat. Okay. netcore dot timer q timer. Okay, I'm gonna guess that this right here is. Yeah, I can't actually go in that. I'm gonna guess that this is like implemented under the hood, like this is not a C# implementation right here. Or is it? Timer Q timer? It is! Wait. If used net core timer. Well, what the hell? Let's call it anyway. In here, it is using this, because this is not net core. Okay. Execution context dot capture change due time period timer queue dot instance prevent thread abort while updating state. Okay, so there's just a timer queue, which appears to be like a singleton. Okay, it is a singleton. So we take a timer, we add it to the timer queue, and then I guess the timer queue is just constantly trying to run in the background. Ensure app domain timer fires by app domain timer callback. Okay, so the app domain calls the timer queue. Like, how many layers do you need here? Okay, so the app domain occasionally it was like, you know what? Why don't you just check all your timers? And then the timer queue apparently just says fire next timers, which literally just goes over the timer queue and looks at all the timers. Okay. And then tries to do them. If due time is less than next app domain timer duration. This is a repeating timer. Schedule it to run again. Okay. Well, that makes sense then. So the app domain calls this thing every once in a while. I'm not going to go any further than that. I think that's fine. Okay, great. So the long and short of it is, our new version. Let me clean this up a little bit. Pipe continue. I don't actually want to print these out anymore. So let's get rid of this. We don't need these things. We don't need this. I'm going to shrink this a little bit so we can see a little bit more code. We're going to run it one more time. I believe the finally block is guaranteed to run interrupted, where normal code can be thread.aborted. So the finally block is not guaranteed to be run in all instances. In particular, if you run into a complete crash where you call environment.failFast, it will not run like environment.failFast. If you call that for whatever reason, die. I believe in this instance it will not actually call the finalies. Okay, so we ran this one more time, and what we see is that pipe continue 1978. What we see is pipe continue buffer is actually slower, probably because divvying up the work is a serial thing in this case. All right, so the whole point, the whole problem with the whole thing is that our task.delay was not actually delaying. That is so interesting. That is like so silly. Okay. But if you have an exception in the finally block, it would be bad. Yes. My favorite is when I'm trying to log an error and the error logger errors. Those are always fun. Okay. Unless you have a try finally in the finally block. An error logger is not sensed to generate exceptions normally. So in our case, our error logger logs to a SQL database, and you would be surprised how often that crap fails for whatever reason. There's like so many silly little things where it's like one of the fields in the error logger has a set size, and if you try to send it something, it gives you an error about trying to truncate it, and it's like all of these things are mildly infuriating. They probably should consider resignation if that starts happening. Okay. All right. I feel good here. There's an improvement of about 20%. Well, no, let's figure out the actual number. Let's not just call it 20%. Let's go to calculator. Let's move it off my head. Let's divide it by 2466.2728. Boom. Okay, a 20% improvement. That's right. A 19.8% improvement. I'll take that. That's a pretty good day for something that I am going to be doing where these things literally take on the order of 15 minutes. So that feels like a pretty huge win. And this should also stop all of the fails. Instead of calling batch everywhere, I call pipe everywhere. Or rather, our new pipe continue, which isn't actually a pipe continue. Let's come up with a better name. Does anybody have a better name for this? It's not pipe continue because I didn't use continue like I was expecting to. And in fact, here we can even do configure await false. No, I can't do that. That would have been way too easy. I feel like... What in the hell? Do I need to do an await here? I do, don't I? Static async. Is it static async or async static? Okay. And then I can do this isn't actually helping, is it? I don't think that's actually helping. That's probably not helping. I don't know the answer. Let's give it a whirl. I can say I've contributed. Yes, you can say you have contributed to Stack Overflow now. Well, sort of. Not Stack Overflow proper, but instead the Providence application at Stack Overflow. I work on the team that collects all of the data about users and builds models. And this is something that is going to... Excuse me. This is something that is going to run once a day for a very long time. So give it a whirl and let's see. Where do you want to give it a whirl? I can't actually show any of the code from my work because of reasons. But I'm happy to try it with anything else that you want to try it with. Configure await. Yeah, is there any benefit? I don't think there is actually any benefit here in this. Oops. I think what really needs to be is return, and then whoever calls this needs to call configure await false. No, we're going to put the async stuff in and say it's not going to help. No, you were going to put the async. Oh, right. Well, I don't expect it to help on performance. Actually, it's not even really that big of an issue because I'm running this in a console app at the end of the day. So all of these configure awaits aren't super helpful. I mean, it already had the thread when this ends, and it's just going to take the same thread. There is no... Well, I guess I don't know where this is going to end up. So maybe somebody copies and pastes it somewhere else, and having configure await is actually helpful. But I feel like this one right here doesn't matter. Whoever calls this needs to call configure await. I don't actually know. I don't think the configure await makes it wait on a specific thread. It just captures the thread context and marshals that thread and marshals to the thread that resumes execution. Good question. What does configure await false do? When asynchronous code after the introduction became relatively easy. Let's just go configure. See where you actually start talking about it. This application will freeze and stop working. We have a deadlock. Of course, users of your library will complain because it makes their application unresponsive. Captures the user principal, thread locals, stuff like that. Okay, interesting. It's just a way to come back to the main thread. Okay. So my understanding of configure await is you do end up back on the exact same thread that you were marshaled from. Not just the thread context, because the thread context... Can the thread context actually change? Because, like, for instance, in like a Windows form application, you literally cannot change a property of a form on a thread other than the thread that the form was created on. So if any external thread tries to change the property, it starts giving you hell and throws an exception. So you like literally have to come back to the same thread. That's my understanding. I am not an expert. But I guess my question about whether I should use this or not is like whether using it in here actually matters or if I just want to use it at the end. And like, in fact, I don't even think this matters. But maybe? I can't imagine this mattering. Yeah, it didn't matter. From a performance standpoint, it didn't matter. Okay. All right. I'm going to go ahead and wrap this up. I'm going to call it, like I said, I'm going to call this successful. I would like to thank everybody who stuck around and helped. I am going to come up with a new name. No, that's the one thing we're going to do. We are going to come up with a new name. We're going to call this Pipe something. No, I don't like something. Pipe. Maybe we're just going to call it Pipe. But I can't because there's already one called Pipe. Smoke Pipe. It's not a bad idea. I just change it to Smoke. Let's call it Pipe. Pipe chain. That's like saying the same thing twice in a sense. What if we just call it chain? Nope, it's kind of crappy. I will take any and all suggestions. Chain. The other thing that we could do is process. Process all. Do the pipe. Pipe do the thing. I'm going to go with process all. Or maybe do many. Do all. The only thing here is these are like, I'm going to say process actions. There we go. That's what I'm talking about, right? Here's your action. Or maybe act all. Process actions. I want it to sound, because this always has to be at the end of like a link chain. Because it just returns a single task and there's no results from it. It's sort of like calling a dot for each, I think. Right? If we have a list, like new list int dot for each. See how this returns void and there's nothing you can do about it? You can only do an action. Maybe just calling it for each is actually the correct idea. Yes, it is going to become an extension again. The hope is everything ending up async. For each async. Alright, that's going to be it. For each async. Why is this broken? Because I renamed it. And then I lost my spot. Alright, we're not going to do this. That was not helpful. We're going to do for each async. Yep. There we go. We don't need this crap. Look, see? The code was a little bit easier than this. I think that's going to be it. Do you need max uncompleted tasks anymore? Well, I need to tell it how many threads to create. Right. So I'm saying create that many workers. Yeah. Oh, you don't want to enumerate. All right. Okay. I think that's it. Thank you everybody for joining me. Let's go find somebody to raid. I see a few people. Let's go with let's go with CLW. CLW, I believe, is doing Twilio Quest at the moment. I believe. How can I find that out? Let's do the old play.
Okay, let me hit the rest of the comments here. My grandpa says, we need to get
Oh, so you can actually hear what I'm hearing.
millions of man hours understanding the code / systems they built. Super, 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 super cool. I think you're spot on. The reality is a lot of that code actually still lives and works.
Okay,
and
we're going to go with CLW.
Usually not the case that...
All right. Thanks a lot for joining. Moumst. I can't be saying that right, and I apologize for that. All right. Yeah, thank you everybody for joining. I really appreciate all the help with this. Definitely, like, I would not have identified that was running serially on my own without your help. So I really, really appreciate that. Thank you for the follow. Okay, now I have to say it right. Moumst. Moumst. No. Is there a pronunciation? Or maybe it's your first letter of your last name and then your last name is Oumst. No? Not bad? Okay, I'll take that. All right. I try to get everything correct there. Thank you so much for the follow. I stream from 12 until like... Oh, yeah, no, I'm not French. I don't know how to speak French at all. Oh, oui, muis. Nope, I can't do it. But yeah, I stream from 12 until 2 or 3 o'clock every day, Wednesdays, Thursdays, and Fridays. And I will be back tomorrow. We're going to keep grinding away on some other stuff. And y'all have a good day.